Present here.
This meeting is being recorded.
Dr. Sayyid Arif, Vice Principal Dr. H.V. Shanai, Dean Academic Professor P. Divakaran, our today's session speaker Dr. Anjaneyappa, Associate Professor, Department of Civil Engineering, RV College of Engineering, Bengaluru. A warm welcome to you all for today's virtual webinar organized by the Department of Civil Engineering, Dr. T. Timaya Institute of Technology, KGF, in association with Indian Concrete Institute, Bengaluru. It gives me a great pleasure to welcome all the HODs, faculties, and students of Dr. TTIT and other institutions to this webinar. I welcome our speaker for today's session, Dr. Anjaneyappa. Welcome, sir.
Thank you, ma'am. Thank you.
Now, I would like to brief about today's session speaker Dr. Anjaneyappa. Sir is currently working as Associate Professor in the RV College of Engineering, Bengaluru. Sir has completed Civil Engineering from RV College of Engineering in the year 1992. ME in the Highway Engineering Specialization, UVCE, Bangalore University, in the year 1997. And sir completed a PhD, UVCE, Bangalore University in the year 2012. Sir has total years of 7 years industrial experience and academics 18 years. Sir has interest of research in pavement engineering, road safety and road construction equipment. Not only this, sir has experience of carrying out many pavement surveys and testing for various consultancy firms and other organizations. Delivered more than 200 presentations on various topics of highway engineering in various training programs. Workshops organized by various organizations and institutions. Organized many training programs for engineers of public work department, municipal bodies and panchayat department in Karnataka. Not only this, sir is closely associated with industry. And we are very happy to have you with us for today's session, sir.
Thank you, ma'am. Thank you. Thank you for those kind words.
Session to you, sir. Over to you, sir.
Thank you, ma'am. Thank you for those kind words, and hope I am audible.
Yes, sir. Yes, you are audible, sir.
Yes,
Thank
sir.
you.
You are audible, sir. Now you can share your presentation file, sir.
I think I shared.
No, sir. I was sharing it now.
No, sir.
Give me 1 second. 1 second. Yes, yes. Kindly give me 1 second. I'll share. Yes. Is the screen visible now?
Yes, sir.
Yes, sir.
Yeah. Thank you so much. Thank you, ICI Bengaluru chapter, especially Mr. Pasha, and thank you, ma'am, for this opportunity. And
Thank you, sir.
hope I am audible. In between, if my voice is not audible, or please let me know.
Yes, sir. Yes,
Yes,
sir.
sir. Sure.
Okay, thank you. The topic of discussion for today is sustainable road construction practices. When you look at the title, yes, including me, we all think it is the moment we hear the word sustainability, sustainable, definitely it attracts us. And I think for next 1 hour or so, I'll try to make the discussion, the interactions lively for related to the sustainability in the road construction aspects. We all know we have got a huge road network. We all know, let's say it's about 60 lakh kilometers. 60 lakh kilometers is a very huge road network. This which consists of expressways, national highways, state highways, the MDRs, the urban roads, and some of the service roads, so on. So one side, we have got a huge road network. And when you closely look at this huge road network, Look at the percentage of national highways, it is about 2%. State highways, it is about 4%. And look at the urban roads, it is about 10%. So 70% of the roads are our village roads, right? And only 2-3% are our say put together 4 plus 2, about 6% of our road network out of 60 lakh kilometer is our national highways and state highways. Means why I am presenting this? We have got a huge road network. Means what? We need to construct and maintain these roads quite often, regularly. And then when you look at the higher category roads percentage, it's only about non-urban roads. It's about 6% only. That means there is a big need for this strengthening and widening and capacity augmentation of this 6% of roads. Why? The major portion of the traffic, goods or passenger traffic, is borne by the 6%, and there is a need for uh, increasing the length and the geometry, improving the geometry of this road network, right? But look at the other thing that we should know when we are talking about road network. The roads contribute about 5% of our GDP. 5% of our GDP. That means the contribution to the growth of the society or to the country from the road network is quite significant, very high. It's about 5%. 5%. Having said that, when we are talking about the roads or the payments, what are the different payments that we can think of when we think of the construction of roads? We have bituminous payments, also called flexible payments. We have concrete payments, and we have this what is called ICBP payments, or we have what is called composite payments. Composite payment where one layer can be flexible, other layer can be rigid. So all these options we have when we are going for the construction of payments, we can select any of this road type, and the selection of any road type should be based on, at least theoretically, it should be based on the design that we adopt. The type of payment that we adopt should be based on the life cycle cost analysis, and also based on the sustainability factors. So these things should be the governing council for selection of any road. Unfortunately, are we doing this? If you ask us, I don't think so. I don't think so. I don't think so. So look at this cross section. I have presented here the cross section of the road, cross section of the pavement composition. Means when you dig open the road and see what are the layers we have, you know that road are the pavement. What is pavement? The pavement is the portion, the blacktop portion or the concrete portion where the vehicles move. That portion is called pavement. This portion is called pavement. And when you dig open the pavement, we can see all these layers, So there will be a subgrade, a foundation layer, a soil layer. Generally, the thickness of this layer varies from 300 mm to 500 mm. For all state highways and national highways, the thickness of this layer is 500 mm. 500 mm. And above this soil layer, we construct one more layer, what is called subbase layer, a granular layer made up of the aggregates. So this acts as a load-bearing layer, also as a drainage layer. And above this, we also construct another layer called base layer, Again, this is a granular layer. When I say granular, the layers are constructed using what is called jelly, the broken stones, right? Uh, this is a granular layer where you find the aggregates, the broken stones of different size and uh, shape. So this is again granular layer. So these two are granular layers. Generally, the thickness of this subbase layer varies from 100 mm to 250 mm. The base layer thickness varies from 250. Generally, it's about 250 mm. The widely used aggregate layer, granular layer in our country, for all state highways and national highways, we say it is wet mix macadam, a well graded aggregate layer, granular layer. So above this layer, two bituminous layers are constructed. If it's a bituminous layer, the bottom bituminous layer is called binder layer, and the top layer is called surface layer. So again, base layer is a structural layer, load bearing layer. Again, the bottom bituminous layer is what we say the fatigue. I mean, is constructed to resist the fatigue, the repetitive loading effect of uh, uh, the wheel loads, and the top surface layer, what is called surface layer, we construct to have a smooth surface so that the vehicles ride smoothly, and then to have a sealed surface, and also the top layer that we construct is a dense mix and the strongest mix. So how these layers are constructed or placed one above the another, closely if we look, these are soil layers. This is a soil layer. Above these are jelly layers or aggregate layers or car layers. Above that, this is a block top layer. So, and this is the vehicle playing on the surface. So the layers just below the wheel loads, we have used the strong materials, good materials, and we have constructed strongest layers. As we go down and down, we make use of inferior materials. Why that so? Suppose if you take the base layer is weaker than this block top layers. Again, sub base layer is weaker than the base layers, and the subgrade layer is weaker than the sub base layer. Why that combination or why that style? Because as we go down and down, the stresses generated or the strains generated by these vehicle or wheel loads reduces as depth increases. So the requirement of the quality of the materials also decreases. So that's the reason we make use of inferior materials. If you take the modulus of the subgrade, let's say it's about 50 to 100 MPa. So if you take these jelly layers, it's about 200 to 500 MPa. These jelly layers. And if you take these bituminous layers, the modulus varies from 1500 to 3000 MPa. So that means why strongest? Stress is more. Why lower modulus? Because stress is less. So that is how the layers are constructed. And in this picture, I have shown you the critical locations of the payment layer system. So you have all the layers here: subgrade, granular subbase, granular base, and bituminous layer. This is called binder layer, and this is called surface layer. Generally, the surface layer that we use is bituminous concrete, and the binder layer that we use generally in our country is DBM, what is called dense bituminous macadam. So these are the wheel loads. So what are the critical locations or important locations? The surface just below the wheels is important to us because that is where we get tensile strain. Tensile strain, right? Strains are stresses. And then below the bottom of bitumen, this is a bituminous layer. Below this bituminous layer, uh, what do we get? We get tensile strains, and compressive strain, and this is a subgrade. This is a subgrade soil layer. Above that, this compressive strain or vertical strain is another critical locations. Totally, there are three critical locations. One on the surface of the bituminous layer, one on the bottom surface of the bituminous layer, one on the top of the soil layer. So these, if we want to keep the health of the payment layer system in the good condition, or if we want to serve the payment completely for its design service life, we have to ensure that these strains are well within the limits, specified limits. So if the strain exceeds here, what happens? We get cracks on the surface. Again, if these strains are exceeded, again we get, because of this tensile strain, the cracks are propagated from the bottom. So this is bottom up cracks. This is top down crack. The crack starts from the top and goes down. If these strains exceeds here, the cracks propagate from the bottom and goes towards the top. And if the strain exceeds here on the surface of the soil layer or on the subgrade, so you get plastic deformation. So you get what is called depression here, what is called the rutting, and even cracking, potholes, anything can happen if these strains exceed. So keeping the strains or stresses well within the limits is very important if we want to keep the health of the payment in the right condition. So, having said that, look at this figure. This is one of the photo that I have taken from one of the stretch in Andhra Pradesh, National Highway NHI stretch, National Highways Authority of India project road during its construction phase. What I would presenting here is I want to see this height of this embankment. This very huge embankment. If my memory is correct, this is around 7 to 10 meters, I believe, the height of the embankment. Why this embankment? This is called embankment. These embankments are constructed to run the road at the desired vertical level, right? Because there is a valley here, and we want the top of the road to run at this level, we construct this embankment. So look at the height of the embankment, it's so huge. And I am sure that you have seen the width of national highways, a multi-lane national highways. Uh, at least that will be about 20 meters, right? 20 meters height or more than that, minimum 20 meters. Or even if you take a state highway, the width of the state highway, two-lane state highway, is about 8 to 10 meters. So that means, imagine what is the soil for a 30-meter width and for a 8 to 10-meter height. So you yourself calculate what is the quantity of materials the soil required. So that is what I want you to just observe. The other photo here I am showing you. Look at this is not man-made. Uh, Nature has made to itself, and of course, it is not natural because we have the constructed the embankment. There is a diversion of the stream, and because of the diversion of stream, this valley or this shape is created. So that means earlier water was flowing somewhere, and now it is flowing here because somewhere the embankment is blocking the flow of original flow of direction of the water, and because of that new directions, new streams are created which were not there before constructing this embankment. So one is huge quantity of materials are required. The other one is there is a separate new streams, new silting, new erosions are happening, right? These are very simple words, but the consequences on the environment we don't know. I believe it is very dangerous because again it takes a few more years to stabilize by itself. And you should also look at this. There's a greenery here, plantation, forest, and imagine because of this construction activity, the cutting of trees and all those things definitely will be there, right? And look at this figure. These are whatever they have shown you the cross section here, just to have a feel. This is our embankment, and this is our subgrade. 500 mm is subgrade, a foundation layer. Just like the foundation of our building, this is also the subgrade, which acts as a foundation for this payment system, for this layers, for this vehicular loads. This entire thing is called payment layer system, and this is the foundation layer. All the layers rest on this, and this layer has to be strong, right? So that the life of this load can be extended. If suppose if this layer is weak, then the whole layers collapses. I mean, they become weak, and we get cracks, potholes, etc. Look at this layer. This is granular subbase layer, GSB layer. Look at this is, as I said, this is made up of different sizes of jelly, right? In the known proportion, the sizes, the gradations are all fixed. They are all given by the specifications, Ministry of Road Transport and Highway specifications, different sizes, and accordingly we have to use those sizes and construct these layers. So this is a granular subbase layer. The purpose of constructing this layer is to transfer the load from the top layers onto the subgrade. Number two, to act as a drainage layer, because the water enters from the sides, water enters from the top. So this entered water, end of the day, we don't want to go and get into this soil layer or to the subgrade, because the moment you find water moisture in the soil layer, the foundation becomes weak, and whatnot, all the distresses, failures starts happening. So if this becomes weak, so we don't want that. To avoid that, we construct this GSB. Apart from load bearing as a structural layer, the main intention, other main purpose, it takes out water that entered from the top sides and leads on to this longitudinal drains, keeps subgrade safe through that action. And above this, we have another granular layer, wet mix macadam. It's a called base layer. As I said, the commonly used base layer in our country is wet mix macadam. And why this layer we construct? We construct this layer to take care of the stresses generated by the wheel loads. So otherwise, it's a load-bearing layer. Practically, if you look at these two layers, they look same, difficult to differentiate. So one is gap graded, means what? You have more voids to facilitate permeability of water, flow of water. This is a dense graded mix, otherwise a well graded mix, so that the stability density will be more. So that the stress bearing will be better, and the distribution of the stresses also will be better. So if above this, we construct what is called the bituminous layers. So these are the bituminous layers, and the bottom layer, as I said, is called binder layer. The commonly used binder layer is called dense bituminous macadam in our country, and the top layer is called surface coarse. Commonly used layer, as I said, it is bituminous concrete. Why do we construct this binder layer? The road is subjected to repetitive loads, and because of that there will be fatigue, and these binder coats acts as a fatigue resistant layer and also a stress bearing layer. So it takes up all the V loads, stresses, and transmits onto the layers below effectively. And the surface course, as I said, why this surface course? It's a very strong layer, dense graded mix, a sealed layer, practically impermeable layer, so that water do not gets in practically. Of course, water always enters. And then the surface layer should give a smooth riding surface so that there is a comfort for the vehicles and the people. So look at the picture here. Uh, And look at this. I want you to see this. The greenhouse gases from the transportation sector is about 14%. We don't want. We don't want greenhouse gas emission. The target is to keep these emissions as low as possible. Approximately, the statistics says our contribution, transportation sector contributes to about 14% of the total greenhouse gas emission. Uh, that is, buildings contributes only 6%, and industry 21%, and agriculture, forestry, and other land use 24%. Electricity, thermal production, heat production is about 25%. So that means we are fourth biggest contributor to the greenhouse gas emission. Means what? That is not good. So ideally speaking, the greenhouse gas emission should be least, but unfortunately, so our level, our contribution is quite significant. The question is, how can we reduce this greenhouse gas emission from our sector? This is where all working should be, and that's what globally people are working with. So in that 14% of greenhouse gas emissions, look at this. Roads alone, your transportation sectors includes our rail, water transport, and air transport, road transport. So road transport is the biggest contributor. 72% of transportation sector greenhouse gas emission comes from the road sector. The contribution from the air and water is very less compared to the road sectors. That means we are biggest polluters, right? We are the biggest polluters within the transportation sector. Now, when you look at the greenhouse gas emissions for the construction of 1 kilometers of the road, look at the statistics. Of course, statistics is a statistics. You see this. So the carbon dioxide emission is about 3234 for an expressway. A rural road is 100, and a gravel road, the road which is not asphalted, is about 100. So look at the equivalency factor. An expressway contribution of greenhouse gas emission is 100 times, and the rural road is about 3 times. So that means more and more is the quality of the road. Bigger is the road, wider is the road, more is the contribution. I mean, greenhouse gas emission, which is not desirable. So the whole target is how to reduce. If you look at the sustainable goals, development goals of United Nations, the reduction of the greenhouse gas emission plays the leads the goal, other important goals. So the picture I have presented here is a crushing plant location. where the boulders, after we blast, wherever the hillocks we find, where these rock sources are found, there we do the controlled blasting. After the controlled blasting and drilling, we get what is called boulders, and these boulders are brought to the crushing plant location. This is called aggregate crushing plant, where these boulders, big size aggregates, are broken to or crushed to smaller size, construction size. What we say 40 mm down, 20 mm down, 12 mm down, queritas, chips and all produced here. Look at this construction site, and so much of dust, and so much of energy is spent on this crushing. Right? And one is the air pollution. I don't think if you go and stand in the crushing plant from morning to evening, you will not stand for more than 1 or 2 hours. I bet. If you go as a civil engineering student or the civil engineer, I don't think you will stand there for even 1 hour. I don't believe. So much is the pollution in these sites. And the other part I would like to present you here is the energy that we spent on this crushing. Right. So this is another pictorial presentation I'm presenting here. When we produce what is called the asphalt mixes, bituminous mixes used for the construction. In the production process of these bituminous mixes, lot of carbon dioxide, carbon monoxide emissions we find. Again, I repeat here, even if you go to this side where these bituminous mixes are produced, you will not stand there for more than an hour, right? So much is the pollution, so much is the emission. There is another table I have presented here. Look at this table. I have placed in this column the different types of the plants and equipments in the road construction. Plants and equipments in the road construction, starting from the crusher and where bituminous mix is produced, hot mix plant, the excavators, the dozers. So many equipments, the rollers, the pavers, and so on. And I have presented here the consumption of the diesel. Look at this per hour consumption I have presented here. The consumption varies from 2 liters to 60 liters per hour. Suppose if you are operating a crusher plant of 300 ton per hour capacity, it consumes 70 or 60 to 70 liters of diesel per hour when it is running. And the smallest consumption is about 2 liters per hour, that is for a water tanker. That means huge consumption of this diesel, fossil fuel that we are consuming today during the construction of the roads. And here is a small approximate calculation I have made about the diesel per liter, per kilometer, per lane construction of a new road. How much is that? About 10,000 liters of diesel is consumed for the construction of 1 kilometer of road of 1 lane width. So, just imagine all these things. And now, look at this picture I have shown you here, presented here. This is a hillock. This is a small hillock I have shown you here. Let's say, for example, this Bengaluru-Chennai road, I think you might have heard, we are doing the expressway between Bengaluru-Chennai. So, it's about, I believe it's about 250 kilometers or so. It passes through, I think, somewhere in Bangarpet, KGF, your place. For the construction, if you construct an expressway of 6 lane and 10 lane and for 250 kilometers, by the time you finish, I don't think 100 kilometers you find this hillock. Completely, this hillock will be vanished by the time we construct these expressways. Right? Completely, literally, practically. I am not exaggerating. So that means to say, we consume huge quantity of aggregates, let's say about 10 lakh cubic meters of aggregate. What do you mean by 10 lakh? Just imagine 10 lakh means one tipper carries 5 cubic meter. A big tipper, big lorry carry about 10 cubic meter. Imagine 10 lakh cubic meter. Maybe after this session, you just imagine what do I mean 10 lakh cubic meters of aggregates for 100 kilometers of four lane. Right? 4-5 times of that, the soil consumption. At least 2 times, 20 lakh cubic meter of soil. You may think, what is there in excavating soil? Yes, we are disturbing the existing the soil condition. Because of that, in the initial slides, I've shown you there can be new erosions and new sedimentations and so on. Right? It is not just for new construction alone. Even after the construction of any road, there is a maintenance. It's a continuous process and required process. Even for that, we need about 175 cubic meter about per kilometer per lane. Per lane means 3.5 meter wide for every 5 years approximately. Right? So that means to say, look at the road network we have. What is the even for maintenance? Forget about new construction. For new construction of four laning, we need 10 lakh cubic meters of jelly, 20 lakh cubic meters of soil. Even for the existing roads, we need 175 cubic meter for 3.5 meter. And I showed you the road network we have 60 lakh cubic meters of road network.
Sir? 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 Anjaneyappa, sir?
Sir, you are there?
Sonam ma'am. Sonam ma'am.
Sir, tell me, sir.
Madam, ಇದು ಸ್ಟಾಪ್ ಆಗಿದೆಯಲ್ಲ ಮೇಡಮ್?
ಹಾ ಸರ್, ಅದಕ್ಕೆ ಕೇಳ್ತಾ ಇದ್ದೀನಿ ಸರ್, ಅವರು ಕೇಳಿಸ್ಕೊಂತಿಲ್ಲ.
ಮೇಡಮ್,
just a second sir, we'll try to contact them, him sir.
ನಾನು ಫೋನ್ ಮಾಡಿದ್ದೀನಿ.
Okay sir, okay.
Is the lecture is over?
No ma'am, kindly wait ma'am, some network issue.
Okay. And madam, feedback form is there for this?
Yes, feedback form will provide at the end of the session, madam.
And certificates are also there?
Yeah.
Anjaneyappa sir.
Sir is joining sir.
Okay madam.
Okay.
Ma'am, is the screen visible now, ma'am?
Yes sir.
Yes sir.
Yes sir.
Sorry for that inconvenience. Now I
That's
change.
okay sir, no problem.
Thank you. So I think I believe I was illidna.
Yes sir. Continue ಮಾಡಿ sir.
Yes. Thank you. So to summarize, there are big challenges before the young engineers, you people especially. You have many challenges as a road engineer, as a civil engineer. So a huge road network, the development is very important, all these roads. And the consumption will be going to be of these materials will be a huge unwanted task. And what are the solutions for this? And how do you face these challenges? How do we find the solutions for these challenges is the biggest thing in front of you. So what are those challenges? Some of them I have summarized here. Good sources are depleting. Especially for subgrade, we try to use good material, good soil, which many times may not be available just in the construction site. So we go 5-6 kilometers, 10 kilometers, sometimes even 20-30 kilometers away from the project site. So that increases the transportation cost, apart from depletion of soil sources, the transportation cost also increases. And there are, as you already know, there are regulations for the use of natural materials. This extraction of these aggregates and quarrying and all, there are a lot of restrictions. And as you know already, the sand is not allowed even for natural sand for the construction. So new erosions, new sedimentations, new streams, new ditches we are creating in the name of road construction. These are all not good, all these things, and we need solutions. On one side, we need good roads for the development of the society. On the other side, we need to reduce consumption of these natural resources. And the other side, we need to reduce the greenhouse gas emission, right? Otherwise, there's a global warming and etc. etc. So all these things are biggest things, challenges in front of the road industry and front of us being civil engineers. So to take up this new technologies are what today the society needs, the industry needs, what is called sustainable technologies and new technologies. I don't know what new technologies. And there are some technologies, sustainable road technologies. What do we mean by road sustainable technologies? I just listed some words here. So the sustainable technologies should produce sustainable roads. Means what? Durable road. That means roads are designed for 20 years, 30 years. Nowadays, we are talking about roads, design of roads for 50 years, 30 years, 40 years. So that means the road should sustain for its design life, serve its design life, durable. Maintenance should be less so that consumption of materials will be less. Low energy consumption. All the materials or the road that we construct should have low embodied energy. We should use recycled materials. Road should be permeable so that the groundwater recharge or all those things happens. Should not produce heat. Should be smooth, aesthetic, long lasting. Cost should be cheaper. So you can keep on adding many other words for this. So for all this sustainable, when we think of sustainable road technologies, what the people are talking, or even when you refer some books and what we are talking today, are some of these alternatives. We should try to use as far as possible locally available materials in the design and practice. We should go for stabilization, use inferior materials, stabilize by using a natural stabilizer or a commercial stabilizer, so that your modulus increases and strength increases and durability increases. You can make use of weaker material. And the other alternative is we should try to use the same materials, reuse the material so that the consumption of new material decreases. And there are some mixes. Generally, the energy that we spend on construction of the conventional asphaltic roads, that means you might have seen the production, the asphalt mix or bituminous mix is produced at a very high temperature, 130, 140, 150 degrees centigrade. So much energy is spent. So there are technologies where we can reduce the temperature, production temperature by 20, 30 degrees centigrade by adding some additives, what is called warm mix additives. They're called war asphalt mixes. And we can also think of using what is called, instead of heating the mix to a very high temperature and then constructing, there are chances or there is a need to use cold mixes wherever possible, where the heating is not required. At atmospheric temperature, these mixes can be produced and constructed so that so much energy, so much emission is reduced. So these are some of the alternatives that people are thinking for last few decades. Nothing new here, but unfortunately or fortunately, all these things, like you, I have also read in the textbooks for last 3 decades or even more, since from my post-graduation days. But when it comes to the practices, if you ask me, not at all significant. I don't know whom we should blame, but that's the reality. So there is no need to reinvent the wheel. Most of these technologies are proven, and only thing is for adoption to the field, for the field implementation, some more supervision, engineering supervision, attentiveness is required. And what I am suggesting you people, you being the young engineers, apart from these alternatives, what I am talking, which we have been talking for last 3-4 decades, still not seen the light of the day in a big way. You people should come out with some kind of innovative solutions, what people nowadays call out of box solutions, or innovative solutions to these problems, so that people, the stakeholders, the government, the contractors, the consultants can adopt easily without hesitation, and so that the global warming and all this consumption of materials are all taken into consideration. So there's a big challenge. People who take challenges, who try to give real solution to the society, they should think on this direction. And that's what UN sustainable goals also specify. Now, just if you take soil layers, one by one we'll discuss. Just take soil layers. Density is very important for a soil layer, subgrade and embankment layers in the road construction. That means density means what? Higher the density, higher is the modulus, higher is the strength, more is the life or durability will be more. So huge quantity of water is required. The other thing that we have forgotten during the construction, we need huge quantity of water. If you look at, if you remember that OMC curve, fracture compaction or modified fracture compaction, at some point at OMC only we get the highest density. That means to need higher density, to achieve higher density, we need more quantity of water. So consumption of huge quantity of water is another big concern. When there is no water for drinking, how to reduce the consumption of water is another big question. Of course, we can increase the compaction energy to a certain extent and reduce the consumption of water. And the moment we increase the density, the CBR also increases, which is an input parameter for the payment design. That is what I have shown. So that means, look at this. I have given some statistics here. Water consumption more than 1 lakh liters per kilometer per lane for a new road construction. Let's say your Bangalore-Chennai expressway needs so much per kilometer. Imagine what is that 1 lakh liters means. So if you take if you ask me which is the most precious material, construction material, I would say the water, most precious than any other material. So how to reduce this soil layer, how to increase the density of the soil layer by using any innovative method should be the question for you. And then look at the other type of layers, what is called jelly layers, aggregate layers, these layers. Here we need density, we need more water, right? So if you take these jelly layers, right, the strength of these jelly layers comes from interlocking through confinement. Either side we need to confine. And how to reduce this, the consumption of granular layer is another thing. And for quality of the gradation, these jelly layers, one of the most important thing that we should remember is gradation. So the defined size and shape in the known proportion is very, very important for a quality of jelly layers. Then comes the bituminous layers above these jelly layers. For a bituminous layers, always when you want a durable bituminous layer, this gradation, which means the size and shape of the jelly, and the temperature at which the mix is produced, at which mix is laid, compacted or rolled is very, very important. So the heating process, if you overheat, the quality goes down, right? If you heat for longer duration, the quality goes down. So good construction practices also increases the life of the bituminous pavement. So this is the energy used by the different asphalt mixes, right? Say for a cold mix, we need what is that, 100 megajoule per ton, and similarly for a hot mix, it's about 700. I was talking to you about warm mix about 650. So that means if you keep using more and more cold mix, the energy consumption, the global gas emission will reduce. And this is the energy consumed or greenhouse gas emissions for different types of bituminous layers, hot mixes, cold mixes, right? Kg per ton for a cold mix, 40. Here it is about 50, right? So if you look at the design, when you go for the pavement design, this is what the conventional design that we do today, where your subgrade, jelly layers and bituminous layers are there. And when you design with a recycled material, a stabilized material. Stabilized means you have used conventional jelly layers, aggregate layers. Instead, if you use some stabilizer, cementitious material is used, and these layers are stabilized, like cement treated base, cement treated sub base instead of this. So there are two things that happens: the thickness reduces, the strength also increases. So we can design with cementitious materials, add some percentage of cement, lime or a commercial cementitious material, so that the thickness of the pavement is reduced. What do you mean by thickness? When thickness reduces for me, the consumption of materials reduces. That is where we are looking at. And strength also increases, durability also increases. Right. And we can also design the pavement with reusing the old materials. Generally, what's happening today, when we go for strengthening and reconstruction of the existing pavements, generally the practically we don't reuse the materials, the jelly, the soil or the bituminous material. We throw them in a poor way, not in a scientific way, or even if we use them, we are not optimally using them. So we are not designing, we are not using the reclaimed materials. What is more important? We have to redesign the pavement using the same, or we should make use of all the removed materials, right? That is another way. Redesigning the pavement with reclaimed materials. Again, what is the advantage here? We can reduce the consumption of new material, so that because we are using reusing the material. So what we are doing in practice, in reality today, we are all doing conventional design for all the development of whatever all the roads which you, me see day in and day out. We go by this method. That means we are consuming fresh materials, fresh soil, fresh jelly, fresh concrete, etc., etc. Instead, what is required is we should adopt these technologies. And if you ask me the technology for these two, it is already there. As I said, 30, 40 years I've been reading, listening. But when it comes to the practice, somehow the stakeholders, whether the clients, the consultants, or the contractors, are not practicing. Yes? Am I audible, sir?
Yes, sir. Yes, sir.
Yeah, thank you. Thank you. Now, so what is the people are talking today? We are talking about long lasting payments, a payment to be designed more than 50 years for a very huge traffic as big as 300 million and standard axles, and we need to keep the strains very less as 80 microstrains in the critical location, that is tensile strain locations, a compressive strain less than 200. So, and this is another just figure I am showing where this kind of permeable payments wherever possible can be adopted so that the groundwater can be reused, stocked, depletion can be reduced, whether it is a asphaltic payments or a concrete payment or a ICBP payment. These technologies can be adopted, not for higher category roads, definitely for other types of roads, these things can be adopted with, there are some limitations, but we should think how can we construct roads which are more eco-friendly, right? Then you here and there we are seeing big cities, we are going for what is called white topping. What is this white topping? We are constructing a concrete road over the bituminous road, or what is called a composite pavement, or we can construct, there is an existing asphalt concrete road, over that we can construct a asphaltic road. So by doing that, what is that we are doing? Let's say this is the conventional pavement, a soil layer, a jelly layer, a bituminous layer. The critical location, let's say the critical tensile strain, as I said, is below this bottom layer here. So if we construct a cement treated layer, a cement bound layer, cement stabilized layer, so what happens? This location shifts to the bottom. That means it lasts longer. The strength of the pavement system increases. Right. So here and there, people are going for this stabilized roads, not in a big way. So people use the lime, mix the lime for the weak soils and construct, or even for the good soil, they construct what is called subgrade, a stabilized subgrade. How stabilized subgrade is constructed? When a good stabilized subgrade, a subgrade with a very high modulus or very high CBR is constructed, naturally that all the layers that we construct above decreases. You know the input parameter for the pavement design, the traffic and the CBR of subgrade. When CBR of subgrade is increased, the top layer, the thickness of top layer decreases. This is how a pictorial, real picture I am presenting here. So the lime or the cement is spread over the subgrade layer, and then it is mixed, and then it is compacted using what is called pad foot roller. You can see the pad foot roller, vibratory roller. So after that, using the motor grader, the surface is leveled, and then it is cured, compacted and cured. So this is how a stabilized subgrade is constructed. What is the advantage? We can reduce the consumption of aggregates. So this is how a stabilized subgrade is constructed. Second, there are some videos here. So this is another picture, and then again this is called a stabilizer. So you can just a small video present, just you can enjoy how a stabilized road are constructed.
For soil improvement, the all-wheel drive Strymmaster
Instead of lime, cement also can be used, or any other commercial stabilizer also can be used.
All-wheel drive Strymmaster SW19SC Rhino pre-spreads the binding agent. Computer-controlled metering feeders guarantee highest spreading accuracy regardless of the spreader's travel speed. Following behind the binding agent spreader, the powerful milling and mixing rotor of the Wirtgen recycler mixes the soil and pre-spread binding agent to produce a homogeneous mixture. The pressurized scraper at the rotor plate levels off the recycled material to create an even surface.
So this is a pad foot roller and this is a grader.
Single drum compactor with pad foot drum then compacts the homogenized soil mixture, its penetrating action going really deep. Finish grading is performed next using a grader. A single drum compactor with smooth drum follows right behind to complete the compaction process.
So that is how this is constructed. So this is a real picture you can see here. So lime or cement is spread, and this is the mixing unit. So after mixing, so that means this is a stabilized subgrade layer. This is how it looks, and this is another video where how the cement is spread. Right? Cement is spread in the known quantity. So this is how cement mixing is done again. So construction of the stabilized roads is very, very important. I think there is no video. So these are the pad foot rollers when the soil has got high plasticity, or for stabilized layer, generally we go for this pad foot rollers, not sheep foot rollers. So vibratory rollers, this for a typical vibratory rollers, this is a casing that is covered for better compaction to achieve better density. So that is stabilized subgrade. Even the GSB and base layers are also stabilized. This is another view, stabilized, and this is stabilized base layer, right? GSB layer. This you can see this is jelly. What we saw in the previous picture, stabilization of the subgrade, and now you can see the stabilization of granular layers. This layer, particular layer, is the sub base layer. So this is how cement is spread, and right. So why do we spread this? The modulus is increased. So on the moment the E value is increased, naturally the thickness of the layers can be reduced. So after that, once the cement is spread, both the cement and jelly is mixed. You can see the mixing, and you can see here. This is how a cement treated sub-base layer is constructed. So we saw the subgrade. Now you can see here this sub-base, a pilot project, right? This is not very common in our country. So much materials can be saved, is what the statistics they say, the company which constructed this. CTSB stands for cement treated subbase. So you can see here, so much is the reduction in thickness if you go for cement treated layers. So much, imagine 140 mm into so many kilometers. So this is a mixing unit, augers. So homogeneous mixing is very, very important. This machine helps in homogeneous mixing, uniform mixing. So all these are, as I said, pilot projects, not widely adopted and practiced. All these things should come in to the practice. Not only this, and you people should come out with innovative ideas for reducing the consumption of materials in the future. So this is the compaction. After the compaction, grader goes and levels, gets the required profile, right? And then recycling is another important. I was mentioning these also should be practiced in a big way. Unfortunately, we are not practicing. So again, recycling also, I mean, reusing the same materials is very, very important. Use the same jelly, same aggregate, same bituminous material. You can see here, same materials can be used. Same bituminous materials can be scarified and reused. Of course, when we go for scarification of the existing bituminous material, this is not the right approach. This is the right approach. We have to use a milling machine than using a backhoe. So that here the controlled milling helps us to get the materials in a good way without disturbing the bottom layers. So we should practice milling. We are practicing milling, but we are not practicing the reuse of this milled material. So that's what is very, very important. You can see, one second. Give me 1 second. So this milling, so we have to go for milling so that we can carefully remove the materials and reuse those materials, especially the bituminous materials, right? So this is a milling machine, cold milling machine. This is an existing road. They are removing the top layer, and this materials is reused again. These materials can be reused. When we go for this is a typical machine where the bituminous mix are produced, and for the same machine can be used for using the recycled material also. Only thing is we get additional attachment. Unfortunately, we don't buy that attachment. Without that attachment, we buy this machine for production of mixes. Why contractors do not buy? Because there is no pressure from the other stakeholders to use reused materials. So for the same machine, there will be a separate bin for the reused materials, and these materials is used in a small proportion, less than 30% in the bituminous mix, which can be used in the regular construction, especially for the bottom bituminous layers. So even, as I said, there is no need to reinvent the wheel. When you look at the properties, required properties of this bituminous mix, all these properties holds good even if you use recycled bituminous material. All these are the properties: stability, flow, air voids, voids in the mineral aggregate, voids filled with bitumen. So the recycled mixes are also as good as the virgin mixes, and these are some of the actual designs that we have carried out for one of the pilot project in the Karnataka. Look at this: by adopting alternate technologies, the right, using the recycled materials, so you can reduce the crust thickness. See here, this is the crust thickness, alternate design. This is the conventional design. So much can be reduced. 440, here it is 570. So approximately about 130 mm thickness can be reduced. So the savings can be, what is that? 49% savings can be achieved, or otherwise per kilometer about 2000 cubic meters of materials can be reduced. This is another design for another traffic. So again, here also about 2000 cubic meters of materials can be reduced. Look here, for a big heavy traffic, 50 million standard axles, there is a theoretical, at least there is a 80 mm decrease in the thickness when we go for alternate design, that is using cement treated subbase and a cold mixes. This is our conventional design where regular layers are used. Similarly for another traffic, similarly for different traffics, and these are worked out, and about 200 cubic meters are savings can be achieved. So in spite of these technologies available, some level of technologies, still people don't use, don't practice, don't implement. As I said, why? Always there is a resistance to change, and lot of, when you go for some kind deviate from the conventional practice, lot of permissions, approvals are required, which we do not want. We don't put additional effort for all this. And then fear of failure, because we are all in the government service. So, knowing people in the government service, they fear that what will happen to my pension, or all inquiry, if there is an inquiry, if the road fails, when we go for construction of road using these technologies. The other fear is why people are not adopting. Whenever we go for constructing the road with new technologies, more people will come, more visits will be there, more monitoring will be there. As civil engineers, we don't like all this. We don't want people to monitor us regularly, more rigorously. So because of this, I believe these things are not happening. So we want more and more technologies to come, adopting these technologies, and more technologies, other technologies we want, so that the consumption, the greenhouse gas emission is reduced. What is this? Yeah, 1 second. So totally what we want is, we should construct the road which is reliable, which is green. We need green infrastructure. That means we should save natural resources. We should control the emission, right? We need smart road infrastructure. End of the day, what we all need is human infrastructure. This is what any construction that people are looking at, society is looking at. So you and me should work towards this, and you people have the great responsibility, young engineers who are attending to this seminar, this presentation. So it should be reliable. More importantly, it should be green, it should be smart, and above all, it should be human infrastructure. And thanks for the opportunity given by the Dr. T. Timaya Institute of Technology for this presentation, and our special thanks to Professor Manila, the principal, the head of the civil engineering department, for having this opportunity, giving this opportunity, and thank you all for listening to this presentation for last 1.5 hours. So that's all from my side, and open to you for any clarifications and questions. Shall I?
Dear participants, if you have any queries, please ask.
Please ask if there are any clarification, no issue, whether the question is big or small. If I do not know, I'll get you an answer asking other experts, or if I know, I'll try to clarify. Otherwise, I'll ask people or I'll refer and I'll come back with an answer.
Participants, I request you to ask the questions if you have any.
I think my video is not working. Okay.
Mustafa Aminu is there. He wants to ask the question. So kindly unmute yourself and ask the question.
Yes, Mustafa. My video is not opening anyhow. That should not be a hindrance, and you may please ask.
Mr. Mustafa.
Or you can put the question in the chat box. That is also okay.
Question is
Sir,
Yeah.
cold processing, sir.
cold
He's asking for cold processing.
Cold processing. That means how the asphalt mixes or bituminous mixes are produced. One type of mix that we produce is hot mix. That is what the conventional. The aggregates, the bitumen is mixed at a high temperature, 150 degrees, generally at about 150 degrees centigrade. And it is transported and spread at 130 degree and compacted before the mixed temperature falls less than 100 degree, or at least worst case less than 90 degree. So that means a lot of energy is required, lot of emissions will be there. The other opposite side of this is the cold mixes. So the other type of bituminous material that can be used is emulsion. Emulsion is a what? A bituminous liquid bitumen. Liquid bitumen. Emulsion is mixture of bitumen and the water. So there is no heating required when you can directly mix the aggregates in the emulsion. Different types of emulsions are there. So we can use this emulsion such that there is no need for mixing. Or there is another what is called foamed bitumen, where the bitumen and water and heated water is mixed and foam bitumen is produced and mixed with the aggregate. So that is also a cold mix. So all this reduces the energy consumption. The only issue here is the modulus value, the strength of cold mixes are not as high as the hot mixes. So generally cold mixes that we recommend is for low volume roads where traffic is less, and also for the layers, not for the surface layers, maybe at the binder courses and so on. So as of now, this is what the cold mixers are used for, some maintenance activities, pothole patching during rainy season. Again, these mixers can be used. Right. What was your particular question with respect to cold mixers? So there are stabilizers, you say, right? Reclaimed materials. I showed you the picture, the reclaimer machine. And you add emulsion. Emulsion for that reclaimed material and mixed and compacted together in situ, in the site itself, right? In the site itself, the material is scarified, pulverized, and the emulsion is added and then mixed and compacted in situ itself. Those that here and there, those kind of layers are also constructed, of course, in a small way. Yeah. What are the other questions?
Thank you, sir. Any other participants?
Cold processing. I'm asking of cold processing. Did I answer your question, Mr. Mustafa? You can come back again. So when we use emulsions, it is called cold production, right? When we use hot bitumen, it's hot mixes. And if you use warm mix additive, then it becomes warm mixes, where we can reduce temperature by about 20 to 30 degree centigrade. Yeah, thank you. Any other clarification? I don't know. You should ask organizers, Mr. Mustafa, about.
I request Pasha sir to send the feedback link. Okay, now we came to the end of the session. Now I request Professor M. Leela to give vote of thanks.
Very good afternoon to one and all. It was a great and knowledge gaining session. I thank our speaker, Dr. Anjaneyappa sir, for sharing his knowledge and enlightening us through his lecture. It was a great experience, sir. I thank all members of ICI Student Chapter Bangalore for your support and encouragement in conducting this webinar. We look forward for many more. I thank the management of Dr. TTIT for giving an opportunity to conduct this webinar. I extend my thanks to all the participants for being a part of this webinar. Thank you one and all. And special thanks to Dr. Anjaneyappa sir for accepting our invitation in spite of his busy schedule. Thank you so much, sir. Thank you one and all.
Thank you. Thank you so much for the opportunity. Thank you all. Thank you.
Thank you,
Yes,
ma'am.
sir.
Thank you, sir.
Thank you.
Thank you, sir. Anjaneyappa sir, thank you.
Namaskara. Thank you. Thank you. Thank you for the opportunity.
Thanks.